This is a talk on architecture and deeper sort of insights into the belly of live framework and live operating environment. And it is being given by Dharma Shukla, except he's about 3,000 miles away. Dharma decided he doesn't like you guys as much and had better things to do. And so he's giving this talk to this young lady. He would appreciate it. He asked me if this was streaming live and whether he can call in. And Maya was born 2 days ago or yesterday, and he was still contemplating whether to come and do the talk or talk to Maya. I think he made the right decision. So I'll be filling in for Dharma. Dharma and I work very closely. I'm definitely his worst half, but hopefully you'll get a lot out of the session. What are we going to do today? We're going to talk about live services and live framework specifically more in depth. You've probably seen this slide about 1 million times now, so I'll skip it. I think you know what box you're in. We're going to talk about hard problems. If you came to my session yesterday, the first couple of minutes, I still have to set context. You've probably heard some of that spiel. We'll talk about the execution engine itself, the live operating environment, as we call it. We'll spend a good bunch of time with that. And then we'll talk about the programming model. If you came to my session yesterday, this will be a good continuation. We're going to take the next step, show you some features that we didn't cover yesterday, a little bit more in depth, a little bit more advanced. Some of it, if you feel lost, that's okay. We'll make this more interactive, since it is a deeper session. Feel free to ask questions, and then we'll wrap up. So a few observations. This is sort of similar to my Zen slide yesterday, just to help with context. Devices, such a critical part of how we designed and why we designed the live operating environment the way it is. This notion of, not just yesterday we talked about sort of the plurality of devices, just the fact that there are so many of them. Today the thing that matters more is the diversity in devices. Right? Just if I have one PC or 2 PCs and 3 PCs, that's great, but what if I have n number of devices running different OSs, running different stacks, different capabilities, some are headless, some have high bandwidth, some are very low bandwidth, and what does that really mean for you? And there is a lot, if you step back and you kind of project out where you think software will be 10 years from now. And you get a little bit more, I like to use the word Zen, a little bit more theoretical. This transformation, there's really a fundamental transformation you're going to see in software from this notion of, the last 15 years have been all about my PC, my computer, my device. I used to love it when, 1992 or something, you're sitting in a DOS prompt and your entire digital life is encompassed in that DOS prompt. You're in full control. The only thing that's relevant to you are those directories in there. And all of a sudden, digital life has expanded so tremendously that we really are making this shift from my computer to what we're essentially calling my mesh. Right? Your digital life is now encompassed of all these devices, of all this data everywhere, and all these services, and it's a lot harder to manage and live in as sort of a digital citizen. And so when we talk about users' data being everywhere on the cloud, and it's not just one cloud. It'll be one thing if it all lived in one place, but we all know that's never going to happen. It's going to live in your corporate cloud. It's going to live in 20 different types of cloud entities that you trust control, and probably in 100 different styles of clouds of entities you probably do not trust very much. And this data is not just going to be living everywhere, but it's also going to be shared with a lot of people. And different kinds of people, some you trust, some you don't. But this massive data explosion problem across these devices and cloud services really is going to make it very challenging to write great software. It's already challenging to do today. And if you think the ultimate goal is really to create these beautiful, these gorgeous, these loving sort of digital lifestyle experiences with software and make software work for you instead of you sort of constantly having to work for it. Again, I'm going to use my mom as an example. Like, she constantly reminds me how much she has to work for the PCs or the software and the hardware in her life, and it drives her nuts. Same true about applications. That's really going to be the way that people consume this great software you write in the enterprise or in their personal life. It's going to blend together. They're going to span these devices. They're getting that fourth dimension that we talk about, people, again, in enterprise, in your personal life. And it's, again, making our life as software developers more complicated, but also makes us want to step up and take sort of ownership and responsibility of building better software in this world. And for sort of the people element is really interesting because it's all of a sudden that dimension is something we haven't really been used to until the last few years. And honestly, I don't think we've figured it out as software developers. Just because you live on Facebook or Twitter or MySpace or Spaces or something like that, it's a start. It's kind of where .NET was in '91. It's in somebody's. It doesn't really exist, and we're going to have to get on top of that. So the hard problems for us as software developers, different style, different rendering of the hard problems than we talked about yesterday. Data composition. Data composition is one of the hardest things for us today because data is coming from all these different sources, both on clients and on clouds, in different formats with different authentication and authorization mechanism. Even if you talk to the same company, for example, if you talk to live services today, you'll probably notice that you can see the seams between all of these services. And think of that almost, again, we'll go 15 years ago analogy. How many people have programmed in the days of Win32, like the early days of Win32? Come on, every single API looked and felt different. Like just because you knew how to program one part of the OS didn't mean anything for you about another part of the OS. And we've just made that problem 100 times worse, right? Within big companies on the internet and across them. So composing all this data to your application, you have to do all the hard work today, and it really sucks, and you shouldn't have to. Now, there's another element in here. It's a little subtle, but critical to understand. And this is sort of this overlay of what we call the Uber schema. Just because let's assume we all use the same protocols and the same data descriptions. If you went to, let's say, call Evite, and you got somebody's calendar, and let's say you went and called LinkedIn and got somebody's contacts, even if the schemas were similar, there's really nothing that overlays the relationship between data that lives here and data that lives here. And what that means is if I have an Evite, and let's say I have a Halloween party on Friday, and I invited 5 people, and they're in my LinkedIn profiles, if I sucked in this calendar from Evite and I look at these people and I look at the people from LinkedIn, there's really no relationship between that invitation model, right? Even though they may be called the same, there's really no way to navigate across this. And by Uber schema, imagine the ability to navigate from a person to their devices, to their calendar, to files you're sharing, to applications you share, to places you've been together. The ability to navigate data really is missing. And that also makes writing software very difficult. Making data available everywhere efficiently, consistently, we can't have data live all in one place. It'll never happen. That's not the way that software will be written. Think if data is going to be distributed by nature, we have to live with it and find really good ways to make it sort of universally available to applications no matter where they're running. Synchronization is going to be obviously a huge part of this. And this is both, again, as I said yesterday, not just about offline, but really about making sort of consistent caches of data everywhere they need to be, and intelligently, because you don't want to cache everything everywhere. That won't work. And you certainly don't want every application to do that on their own. Writing robust communications code, whether it is you're just calling a cloud service and you're on a flaky endpoint, but really when you're talking about peer-to-peer devices collaborating together, having to traverse NATs and firewalls and understanding bandwidth latencies, and when mobile devices enter the scene, and don't let anybody try to convince you that mobile high-speed connectivity will be ubiquitous and magically work for you in the next few years, because it won't. Sorry, I spent a lot of time working on mobile on Microsoft, and it just won't. Dealing with async and managing state across all this stuff, really, really hard. And it's not that we can't figure it out, but honestly, we're kind of lazy. It doesn't matter how good of a developer we are. Most 95% of us are pretty lazy. We don't want to have to deal with these sort of hard problems, and they should be dealt in for us so we can focus on what we do best, the business logic associated with our app. Disjoint programming models, that's different than schemas. So just because data representation is different, now think about all the operations against the data. So if your programming model does queries one way and somebody else's does it a different way, like with every single data type, just the amount of code you have to write and the complexity of putting an application together just explodes. So between queries and casting and notifications and all the classic operations you want to do. And finally, centralized resource management. That hard problem essentially says if you have all these applications running on devices, on PCs, on servers, and clouds, if every app is going to do its own resource management around synchronization, around sort of data availability and cache management, around sort of scheduling, and around networking and caching and notifications, your machine is going to come down to a pretty grinding halt from an experience perspective. Not that we need any more processes running on a Windows machine, but you get the idea. And so this was a lot of the reasons we built the live operating environment, and the way it is designed is influenced by thinking about those hard problems and how we think they'll evolve over time. The live framework, as we call it, in the live operating environment, is the service composition engine, as we touched on yesterday again, of how do you take all these disparate services, some owned by Microsoft, some potentially not, and really compose them into a common programmable endpoint that a developer can trust to have a consistent schema, consistent set of operations, available across cloud and clients, and really give you that starting point for building applications in this sort of digital world. Now, the point of the live operating environment in terms of a programmable schema is really, yes, there's a simplicity element to it, but a lot of it is also to touch on the comprehensive part, that you don't have to continuously learn about all the different elements of these services that you're talking to, and enable you to reflect that same programmable schema on all the devices that you have. And again, I'm going to be careful not to confuse offline and synchronization. Like, it's really about bringing data closer to applications, closer to people, closer to devices, and there's a side benefit, of course, that it can work offline. So taking care of the hard problem in a single common engine, offline and synchronization, centralized resource management and scheduling, communications, device management, user-to-device mappings, claiming, auth-Z, all those things that you should really wake up in the morning and say, man, I don't deserve this. Somebody should have provided it for me. So in terms of existence on cloud and devices, that symmetry, that notion of spanning this PC phone web, as you probably heard us talk about it, but really all devices in the clouds is a pretty unique model for us. All the incarnations, as we'll talk about later in more depth, of live operating environment essentially architected the same way regardless of where they're running. And that's pretty important. We'll talk about why that is. And then that unified, consistent programming model on top of the schema so we can unify operations or how you interact with the data. Is pretty key. All in a fairly open way that is absolutely not unique to any particular platform, programming language, device, etc. So a quick 100,000-foot view of how this runs. Think about all your applications living somewhere, desktops, devices, in browsers, wherever, talking to the live operating environment, either locally in the cloud, which is composing. On this particular slide, you're seeing our services on the back end, but nothing really prevents us from combining other services as well. And let's take a look at a quick demo just to get our minds refreshed before we get too deeply into it. So we open up our browser, and I'll show you a couple of data types that I have living today in multiple services. And by the way, this is actually a pretty important point, so let me take a second on this. No one is saying, we'll admit at Microsoft we have many back-end services that store many different kinds of data, right? Our contacts live in one place, storage lives in a different place, device management, identity services. Like, there's a good reason to have lots and lots of different kinds of services. Nobody's saying one should unify all that stuff into a common endpoint. The common store and a common back-end infrastructure. What we're saying is there should be a common way to program against it. There is necessary evils around running different services differently, scaling them differently, implementing them differently. So if I look at my live contacts, for example, these are the contacts that we're going to use for today's demos. They live in, think of them as they're part of my Hotmail experience. They live in a particular sets of data centers, particular schema, particular backends. If I go, for example, look at my live folders, a different data type, they live, of course, in my live desktop and the mesh storage backend services. And these two potentially have different implementation. They live in different data centers. They have different schemas, different capabilities. But I don't want to program against them in a different way. And so we have 4 in here, and we have like 10 contacts or something like that. So let's, just for a quick demo, you won't have to watch me write, 400 lines of code we wrote yesterday in 45 minutes. Let me show you how we're going to access these without actually writing a lot of code. And not unique to our API kit that we used yesterday all the time. We're just going to use HTTP. So in this particular example, I'm loading up my network credentials, pretty simple. And we wrote this method to help you sort of get items from a URI. And if you saw Don's and Chris keynotes yesterday, some of this should be familiar. Let's build up an HTTP web request, set the authorization header, get a syndication feed, standard .NET framework, paradigm, and then just go ahead and enumerate through every item that came in the feed. And in our main, make up a request to the live framework endpoint in the cloud. As I said yesterday, user.windows.net is the place where all of user stuff, data, devices, application, people live now, which is very nice for you to worry about one endpoint to program against in the cloud. Set the auth header, make a call to the service document, and then just enumerate essentially through each of the key resources. Service document, there's mesh objects, pretty basic, walking through each collection. And let's just run that for a second and see what happens. We're going to get a token that's going to take a couple of seconds. There we go. There's the contacts that came from one service, my mesh object from another, devices from another. Then The point is that using just basic HTTP, basic request response sort of style, I'm getting data that's probably stored in, my guess would be, 7 or 8 different massive services on the back end, all comes to me in a common sort of schema, common sets of operations, very easy and natural to use. Now, if we do, checking our servers up, if I want to do that in .NET, that's great, but what if I'm not on a Microsoft stack? Let's go ahead and open up a Python shell, like proper Python, not Iron Python. Sorry, I shouldn't say proper, not proper. Iron Python, this is just regular Python. Let's go ahead and run this guy. We're going to do the same thing here. We're going to make a call to the URL that's up here. Notice that I can run this against the cloud or the local URI. We're going to use the cloud URI for this one. We'll do it against the local one in a moment. We're going to use the JSON decoder to make it easier on us, enumerate through the root, enumerate through mesh objects, enumerate through devices, and let's take a look at that puppy in action. There we go. There's my mesh objects that came back. There's my devices that came back. And very simple. The whole point I wanted to make, it's just plain good old HTTP. And if you can talk that, every device programming language stack is welcome to the party. Some guy walked up to me after the stage yesterday. If you're here, I'd love to keep chatting with you. Said, man, I want to write live operating environment for Linux. Can I do that? It's like, hell yeah. God, we'll hire you. Come write it even in-house if you want to. But really the idea is the mesh will never be, I can't imagine we'll be successful in making people's lives better if we only stick to a Microsoft stack. That makes no sense. I'd admit most of my devices at home and my receivers, my TVs, all the media stuff we have, the car, they don't run Windows. And that's okay. There's nothing wrong with that. It's great that my Windows devices are going to behave really well in the mesh, but I'd love for everything else that's sort of net connected to behave that way as well. So actually, we could do let's do another really quick demo. So that was about getting resources. Let's see what it takes to create them, also using HTTP. We wrote a simple wrapper for posting an item. Take a look. The really interesting part is really down here. We're going to create a new live folder into the mesh using just HTTP. Again, it's a lot more verbose than using our managed API kit, but of course, you're welcome to use either. So we're going to create a new request. Set the title of it. It'll be my live mesh folder. Add a category to it. So live folder is a specific type of a mesh object, and so it has to have this category, this type, or we won't recognize it in live desktop. You have to add a new feed to it. Where's our feed? There we go. You have to add a specific type of data feed called live mesh files. Because we model everything as mesh objects, the live operating environment actually doesn't know the first thing about live folders. And it's interesting because a lot of people think, hey, mesh, all I see is syncing files, syncing folders. But really, underneath the covers, we have no idea what you're syncing. It happens to be that the application we have that manages live folders, like live desktop and the client, understands the semantics of a live folder mesh object type. And in order for it to understand that, it uses categories. It uses a specific feed called live mesh files. And that's really all it takes to post a new live folder. Let's go ahead and run that. And all we did there, let's go to my live desktop, hit refresh, and hopefully my new live mesh folder will show up in here. And again, the nice thing about that is if you have a domain-specific application there we go, pretty simple. And we didn't put any data in it, but just the folders there. So if you have a domain-specific application that wants to use mesh objects as its base type, you can create your own categories, extend them any way you want, all over HTTP. You don't have to be tied to any particular implementation or schema that we have. So that was just about HTTP. Let's keep going. And talk about a little bit more. So in terms of always being online, the idea is in the cloud, you want this endpoint to be always available. You want to be able to be available for applications that are hosted in browsers, Ajax, Silverlight, Flash. Somebody was asking if they can build Flash apps. Of course you can. Modulo, any challenges you may have with cross-domain scripting, which we can chat about. Desktop applications, somebody was just asking me about mobile. Absolutely. Now, the occasionally connected scenario, as we call it, we used to call it the disconnected scenario or the occasionally disconnected, but I guess occasionally connected makes just as much sense. The idea is that if your client or our client is talking to the live operating environment in the cloud and has the ability, of course, to talk to other live operating environment instances using P2P, if your application is running locally in the device, you should 90% of the time be using our local instance. We'll take care of sync and auth and P2P and all those stuff on behalf of your application, so you don't have to go and talk to the cloud, and your app can continue to work even if network latency is patchy. You'll also get, of course, much better response times. It turns out for a lot of applications, this is actually a very compelling model because your app doesn't need to have millisecond sensitive data in it. Most of the apps that you use on the desktop today work, good ones at least, work this way, like Outlook. And so if you think about how long it took us, this is also an interesting segue. And think about how long it took us to get Outlook right to the point where it really runs beautifully on your desktop, always using the local cache. It's always up to date. Data doesn't get corrupted. It's always super fast. And it's a pleasure. I have to say, I'm pretty harsh on Microsoft software usually, but it is a pleasure to use Outlook. It just works. It took us about, 12 years to get that right. Now, imagine you wanted to replicate that style of experience across all your applications. Why should you have to do all that work? There's an engineering army at the Office team that works on making this work right, and we think that model really applies to a lot of pieces of software that we can help with. So let's talk about the client and cloud symmetry, and then we'll dive into a few new features that you probably haven't seen before. So get your attention briefly for that. Let's take our Python example, and let's change this to be the local URI. So we're going to talk to localhost port 2048, and now we'll talk about a few tips and tricks in a moment about how to make your life writing code against the local client a little easier. And let's open up our resource model browser. Very cool tool. We'll navigate to, let's find mesh, devices is good enough. So we'll go to the devices feed. Notice we're going to the cloud one. Let's make sure I have Smooth running. We're going to get our device feed from the cloud, and then we'll get our device feed from the client. So if I run my Python app, notice that it came back instantly. While before it was taking, 20 seconds to get an auth token, 30 seconds to get an auth token come back. When I'm talking to the local runtime, I get the same data in the same formats instantly. Why? Because it's there. It's right there. I don't have to make a network call. I don't have to get auth tokens. I get it, and it's instant. And of course, it's exactly the same data as if you're browsing that data model in the cloud. Now, interesting thing about latency, if you are talking to the local client, you do have to be aware, sometimes, you have to be aware whether or not your data is being synchronized instantly. You can ask if you're offline or not. You can check for state. You can check for conflicts. You can resolve conflicts based on data that's local, so you don't get sort of too much cache discrepancy between the cloud and you. You have to be aware that data can be updated not just by the cloud, but at the same time, 7 other devices could be offline, making changes locally. They're all disconnected. They all come online. All of a sudden, you got a very interesting conflict resolution problem. We have some mechanism in place to help you with that, but it is a lot of the time, it's app-level logic that you have to deal with. But the key takeaway here is that both from a protocol format and from just the way you talk to our programming model is really no different. Like, we're going to try to keep it virtually identical across clouds and devices to really help you write software easier, better. And that's pretty provocative, because think about services today. Think about all the services you program in the cloud. How many of them have a program model that's virtually identical on the client? Not many. Many of us didn't even think that that's something we should ask for. And a lot of the times, the features that really have the most impacts over a long period of time, 5 years, 10 years, are things that, not the little things you get from customers, I wish I could do this, I wish I could do that, but fundamentally change the way you think and demand that you should be able to write software that's easier to write in this. We're giving you all these great services to essentially shoot yourself in the foot, and we shouldn't do that. You should have a much easier time writing this kind of software. And I'm going to keep harping on that point over and over. You just shouldn't have to deal with so much complexity. So inside the live operating environment, pretty interesting architecture we picked. We'd love your feedback and thoughts. The live operating environment is think of it as host independent. You get a host on the web. We'll use full CLR, ASP.NET, WCF, whatever we want to run on our front-end machines in any server. It's a rehostable runtime, think of it this way, or service composition engine. On the client, we host it in an exe. And today, you'll see in your process list, mo.exe. It runs on MinCLR, but it's rehosted exactly the same way. So you can take the live operating environment and pick a host, stick it in there, run it. Pretty cool. Now, it has a few interesting components. One, we have the service proxy architecture. The service proxy architecture allows the live operating environment to essentially shield itself and abstract itself from all the intricacies of the services it talks to. So we have a service proxy for storage, we have a service proxy for directory, we have a service proxy for identity, we have a service proxy for contacts, ... You can add as many service proxies as you want, and their model, many of them are ultra thin. They're just doing essentially an adaptation layer between one data type to how it's reflected in our resource model. But the really interesting thing in service proxy is their ability to now create relationships between data from different services. So you can say, ooh, contacts from this database really map to members from here, or people in this particular data type, and they create this navigational experience through the resource model. And service proxies work on the cloud and on the client, which again, pretty fascinating. It has a way to plug in synchronization engines, because not every data type should be synced and managed the same way. So we have a bunch of sync engines, you get to load them, they do their thing, and you are, as a developer, abstracted away from the complexities and intricacies of moving different styles of data around. They can take care of, hey, what shall I sync peer-to-peer? What shall I sync from the cloud? Where do I optimize over the wire? Where do differentials, etc. And a scheduler, of course. The live operating environment does a lot of work on your behalf. It's not free. Complex scheduling system, scheduling engine that helps it do its thing, of course, with a lot of caching. So some of the services we have. We have a script engine. I'm going to show you a lot about that in a moment. Very powerful feature. Today, for gearheads, we'll make it easier to use a little down the line. So we have the ability to execute scripts and do batching and do late binding of script execution. We'll talk about that. Formatters, where they allow us to take different data types and render them in different formats on the wire. So as I showed you earlier, if you want to do them in JSON or Atom, RSS, POX, FeedSync, whatever you want, we'll render that format on the wire. We do resource management on your behalf, and that's sort of scheduling and managing work and resources in the engine. File system management. So we have, for devices that have file systems, oddly enough, not all devices have file systems. We had interesting scenario with a company that builds digital picture frames. Very cool scenarios, but some of their frames literally have no quote-unquote file system. So how do you... We have an ability to watch, what we call watch and realize resources into what the equivalent of the file system would be. So we have ways to manage that, a stack to manage peer-to-peer communications, a stack to manage reliable HTTP communications, long-running requests, notifications over HTTP. We have an app engine that manages your applications when they're running in live desktop or when they're running on the client. It can figure out their updates, how to load them, how to sandbox them, how to secure them from one another, all that kind of good stuff. Throttling infrastructure, make sure that no particular application is being a little sneaky bastard and taking up all the resources in the system from others. Analytics system. This one, I wish I could show you more, because analytics is really fascinating. There's two kinds of analytics. There's analytics about what your application is doing that you can learn a lot from. And there's analytics on what your users are doing that we can share with you that you can learn a lot from. In a, of course, PII responsible way. So for example, if you're using the live framework, you can come to our developer portal, click on the analytics tab, and you'll find out, hey, 30% of my users are from South America. We won't tell you which 30%, but you'll be able to get regional distribution of where your users are from. You'll be able to get, we know their gender because we have 460 million of these guys with profiles in our live ID system. We can tell you, hey, 28% of your users are male and the rest are female. That's a pretty cool service. We'll be able to tell you how much bandwidth they're using. Imagine the ability to ask questions like, what percentage of my users also use this service? For example, how many have Hotmail accounts? How many have Spaces accounts? How many are on Messenger? How many have more than 2 devices? How many have blah, blah, blah? Lots of interesting analytical data. The minute the world, so to speak, is so connected, there's so much data you can use to make your application better, and we're going to help you with that. Authentication and authorization systems on your behalf, notification systems, device management systems. Lots of work that's happening in this engine to make your life as a developer easier. And over time, of course, would love your feedback. What other services should we be providing? On top of this complexity, we layer the live framework programming model, which makes, again, it all sort of trivial to program against. And the building blocks start at the info set. We have a very basic info set I'll tell you about in a moment. So we can represent all this data in a pretty generic way, in a simple way that allows us to render it into whatever format you choose. We have the ability to model resources and relationships, critical. Extensibility, I'll show you some of that in a moment. How can you take your own data types and push them into the system? And then a common naming and addressing scheme, so you can locate and refer to these resources in a common way. Other things, we talked about most of these capabilities like multi-wire formats, CRUD operations, your right to link query mapping, so you can do very nice query capabilities, synchronization, scripts and triggers. So imagine the ability to do triggers on CRUD operations. So you can say, hey, when this resource is updated, the update operation is called, please run this script, almost like a sproc, right? Which is pretty cool. So you can have compensation logic there if you really wanted to, and do all sorts of pretty funky stuff. The last one, I'll touch on introspection. We call this, it's almost like the oh shit handle, right? Like if you're not sure where to go and what the system does, call the options verb, introspect into the system in real time, and will dynamically reflect to you what the resources that you're calling on can do. Very nice feature. Over time, this will enable us to build some really great tooling experiences. The nouns in the system. Everything is a resource. Everything in Live Framework is a resource. Treated looks the same way. Data applications, news, subscriptions, a social graph, all looks and feels the same. They're all URI addressable. They're based on this very simple info set, properties, records, and collections. We do this projection over the wire for each of them. Nice and lightweight for you. They can come from a million different kinds of data sources, which we like. And you really need to think about the mesh object as sort of that base unit of replication, management, extensibility in the system. We'll talk about some verbs. Very basic, and this is how we interpret them. So post, create a new resource. Put, obvious, update a resource. Get, delete, the options verb for introspection. And head, of course, if you want to get without the entity body for some odd reason, if you choose to use that. We have a pretty consistent model for dealing with all these verbs, again, across all these resources. We use AtomPub for CRUD as the model you use to talk to us, and feed sync when you want to talk sync, when you want to move data back and forth between our system with conflict resolution, tombstoning, all that good stuff, and of course, link. Okay, resource scripts. Love resource scripts. You should all love them. You should get a t-shirt that says resource script and sleep with it at night, because it's one of the coolest features you'll ever see. I'm not exaggerating. It's a domain-specific language. It uses AtomPub and FeedSync essentially as a way to define these Live Framework programs. It has a grammar. It includes statements for things like CRUD and sync, control flow, data binding, all that good stuff. Some pretty interesting usage patterns. So you can use it for batching. If you're familiar with systems like GData batching, think of that, but on ++ mega steroids. I suspect that a lot of people will be using it. It's pretty expensive to do a lot of operations against a cloud service. So anything that can help you do fewer requests, more work in one request, push more work to us in the data center is great for you. This is how we do pre and post triggers. This is how we associate with different styles of resources. We have an ability to serialize these programs, so to speak, into JSON or POX, so you can literally just write up a program and hand it to us, and we'll execute it. I'll show you that in a moment. We don't have this working yet, but we're working to add XAML and native DLR bindings, add compensation support in scripting, and one of the niftiest features that we'll take a look at in a second as well is the notion of late binding, the execution locality, what we call it. So you can take a script, define the sets of operations that I'll show you in a moment, decide I want this part of the script to execute on the local client, decide that dynamically at runtime, decide, ooh, this part of the script now I want you to execute for me in the data center, take the results, bind it to something else, keep going. So you have a lot of flexibility. And pretty soon it'll allow you to essentially visually design what we call Live Framework programs as we get our tooling story underway. So you'll almost be able to think of it like the workflow designer for writing operations in Live Framework. So what are the types of statements you can do? All the obvious ones, and with just a handful, you can do a lot of interesting things. So creating resources, reading them, updating them, creating media resources, which is the ability to fetch data from other places. Think of us, we'll make calls outside of our data center on your behalf. Delete resources, synchronizing collections, all the basic ops you need to manage the resource model, which is, again, is hugely powerful. You don't need a lot more than that. Being able to do CRUD against Live Framework gives you 90% of the stuff you need. So control flow. We have the ability to do sequences and think of sequences as like squiggly block in C#. These are statements that execute sequentially. We wait. We don't continue if one of them fails. We have the ability to do interleaving as well. So if you want us to execute things in parallel, it's sort of like spawning your threads. It's more like fibers than threads. We'll manage all this on your behalf. You don't have to worry about it. We can execute them in parallel. You can data bind the results together. We have basic conditionals, essentially like if-else statements you can write inside these programs. There are lambda expressions which return, again, you can also data bind against the results of those, but they return you basically true or false depending on how it executed. We have basic looping constructs. Again, we'll enhance these over time. But just with control flow and assignment statements, so you can, again, sort of move your data between different statements in the program, makes it a very powerful model. And I expect some people will probably just write live framework scripts, resource scripts. So what is the flow or the basic authoring flow of a script? You build a statement DOM, show you how to do that. You compile the DOM, you call execute, and away you go. So again, this helps you avoid chattiness. It helps you avoid multiple round trips. It helps offload some of the work to us. It's a great modularization mechanism, as we call it, because you can essentially encompass portions of your logic into separate resource scripts. You can attach them to resources, send them to us. One day, not quite yet, but one day we'll also be able to essentially allow you to store and persist these scripts. So you can, instead of having to send, and imagine you wrote a really nice big fat program that you execute a lot, persist that thing, send it to us, we'll keep hold of it. And next time you want to execute all that logic, you don't even have to send it in. You just say execute script with this ID and boom. Pretty nifty. We don't have native Silverlight DLR JS support, but it's coming soon. Imagine the ability to, we have run at, think the equivalent, run at server, run at client. Inside the browser, we don't have that quite yet, but coming soon will be the ability to execute that natively and locally with your app in the browser, which is pretty nifty. So let's take a look about resource scripts. All right, let's take a look at a fairly simple example. We'll start with C#. It turns out that 81% of you are C# developers, which is pretty amazing. Let me see, how many people here are C# developers? That's 91. Damn. Okay. How many people here have written code in Python? Wow. Sweet. You guys are the Renaissance man of, say again? All right, let's take a look at this very basic resource script example. Again, I'm going to load my resources from file. This is an interesting URI. So there's a very, very few URIs in the live framework that you should, quote unquote, depend on. Like you can depend on the endpoint, and everything else you should not hand generate. The resource model will tell you where those URIs are. It allows us to do much tighter, more reliable schema when you go geo-distributed and all these services start to run all over the place. Helps us to be much more efficient. But you should not be hard coding a lot of URLs. This is a dependable one. It's your mesh objects URL. This is where they live. This is where we're going to do the resource script work. So what we're going to do in this resource script, we're going to get 2 pictures from the internet. And actually, let's take a look at those pictures just to make sure that they're still there. And we're going to send in a script that says, go and create us a live folder in the sky. Go create a data feed in it. Go get these 2 resources from random places in the world and URIs. Suck them in. Sort of interleave those 2 as you persist them into the live folder. And sort of call it done. So picture 1, there we go, comes from Flickr. Picture 2. And we're going to go to live desktop and create us a new live folder that takes these resources from these 2 endpoints, brings them in, and puts them into our mesh. So to do that, we have the 2 URIs in here. We're going to create a new mesh object resource of type live mesh folder. We're going to call it our PDC album. We're going to create a feed in there called my pictures feed. And that's going to be a live mesh files feed. That's important. Otherwise, it won't be picked up inside live desktop. Now let's take a look at this. I'll let you breathe in for a moment before I start talking and orient you. All right, let's start with a conditional. So we're going to start with a statement that says, let's go ahead and execute this sequence. And this sequence will first do a create resource statement that basically says, hey, would like to add a new resource to Live Framework. It's going to be a mesh object resource type. Give it a little tag, a little slug S1, so you can refer to it later. We're going to ask you to post this resource on this URI. And you know what? Maybe I'll just put a breakpoint in here so we can walk through. Well, we'll run it and then we'll breakpoint through to show you how different parts of this work. When you post on that URI, I want you to post this object. This one right here. OK, so that's create the first resource. And I want you to execute this sequentially, please. After you create the mesh object resource, let's create another resource, which is going to be a data feed resource. That's that live mesh files feed. Now, I have to know where to post this statement, right? Because I don't know ahead of time the URL where I can post this data feed because I don't know where the mesh object is yet. And so we give you the ability to bind the collection URL that where you want to post this next resource on will be on the data feeds link of the mesh object. But since you don't know that yet, we'll allow you to bind that to the result from the first statement. So you can write lots of code even before these resources ever got created. So we're going to say, please create the mesh object. Please create the feed. This is statement 2. Use this object to post, which is this one. Bind the location you're posting on the data feeds link, which is where data feeds live on mesh objects. Great. So that creates the live folder. When you're done with that, please add some data to this live folder. And you can do that in an interleaved fashion because fetching the first photo is not dependent on fetching the second photo, so we can execute those together. So now we want you to create a media resource, which is a different kind of resource. We're going to call this S3 statement so we can refer to it. The URI that we want you to fetch this from is picture1 URI. And we want you to bind the place that you post this on to the media resources link that came from the response of the previous statement. And so now what you're essentially doing is you go and you fetch a resource from a third-party service and you post it on a URI of an object that didn't exist, which depends on another object that didn't exist when you started this operation. You can see the kinds of clever stuff you can start to do with this style scripting. And exactly the same thing for this statement. Go get a different resource from a different URI and post that back into that same object. Then you call compile. When you call compile, we can basically come back with two things, either good job, buddy, or you suck. If you get the thumbs down, it means one of many things potentially went wrong. One, you try to execute styles of statements that we don't like. We'll try to figure out if you're doing sort of infinite loops, if you're going to suck up a ton of resources that we are not so kosher with. We should probably document all the 1.5 million things that we will validate before we will let you run this thing. Because the important thing to note, this is a little bit profound. We're actually executing this code on your behalf in our data center using our resources. And potentially you may ask us to execute a lot of it, and very frequently. We can try to tell a little bit about whether you're trying to do good things or bad things, but you know developers, we all get pretty clever and sneaky, and you betcha half of you in this room will try to sneak things past us that we're not so excited about. And that's okay. But we'll try to do our best to try and protect the data center, try to protect scripts from each other, try to protect users' data. And over time, this will become, I think, a pretty significant feature that you'll see so much usage of that we'll put more and more structure in place to help you, both for you who have good intentions, but maybe screw up, and those of you who have bad intentions, which we're not as excited about. So you'll compile this thing, and then we'll say, hey, good to go. Now, the cool thing is, once we compile it, look at this. You can take your script, and you can save it. And you can load it later. And you can load it in different forms. And I'll show you that in a moment. You can save it as POX. You can save it as JSON. And then you can decide where you want to run it. So you can just do a script.run, or you can do script.run at server. And you give us the credentials under which this is going to execute. When the script comes back, it'll actually come back and look very different because you sent it in as a request, and when it comes back to you, it comes back with all the response. And so we'll output that to file as well and take a look at what happened. And then you're done executing. You can imagine the demo. The next time we do this demo, we'll be in Visual Studio with a beautiful designer, so you can drag and drop and bind. But one step at a time. So let's go ahead and we'll pause here to make sure that everything is going well. We'll start executing. Let's take a look. Here's picture 1. There's the URL. There's picture 2. And actually, let's just let this puppy run through. Let the script execute, finish up, and output that stuff to file. There we go. Okay, let's see the results. Go back to our live desktop. Anybody remember what did we call this folder? My PDC album. Okay. There's my PDC album. Okay, there should be 2 resources showing up in here shortly. Oh, there you go. Let's click on the media view. Let these puppy load. This is a really nifty little Silverlight controls. Man, the network is slow. So those 2 pics that we went and got from, let's remind ourselves what they look like while we wait for them to load. There is the orb, there's the bridge, there's the bridge, there's the orb. Is that cool or what? Come on, let me see some energy. Very cool. Oh, even cool. Let's go take a look at the files and see what happened. So if we go look in our file system, there is, let's go, man, this font is ginormous. Let's go ahead and take the JSON output, put it in tidy JSON so we can sort of see it. This is that script that we just wrote that got, quote unquote, compiled and persisted in JSON format to disk. And so this gives you a great way to be able to save. You can generate them this way as well, not a problem. If you want to look at the POX one, where's our POX one? That's the output. This is what it looks like. It's kind of beautiful, actually. If I could, I would make pajamas out of this thing. I just think it's gorgeous. Look, it has the media URLs that we went and fetched, collections, the responses, everything you need essentially to execute this program lives in this one sort of tight, compact format. Now, if you go look at the output, now this is a bit more gnarly because you sent us a bunch of stuff, and now look at all the stuff we sent you back. So the entire response, let's go find something interesting in here. The entire response of what happened, where we executed it, what the results were, how the bindings went, all came back to you so you can inspect and load and do something fun with it. Let's show you one other really neat thing. Let's get you. Okay. Now, before I go to the next part, one interesting thing about this is that you can imagine visualizing this program in anything you want. So yeah, you'll have Visual Studio designers, but if you wanted to do like an Oslo model over it, you wanted to do a Visio diagram, and I expect a lot of the creative stuff you guys will do is pick your favorite modeling tool, could be Paint, I don't really care, and go and design these programs in your favorite sort of domain, and I think we'll see a lot of creativity coming from that. Now, let's go ahead and delete this guy. Let's go delete this album, and we're going to recreate it in a moment. So we'll take the MyPDC album, make it go away. Wait for Live Desktop to update to make sure it's not there. All right. Now let's run this. Check this Python script out. Create a request to this URL. We're going to post it on the scripts URL in the root of the mesh. Let's go load that exact same JSON file. So that JSON file that we just persisted, that had the compiled version of our script ready to go, take that thing, post it on the URL from Python. Don't write anything else. Just post this puppy, and let's see what happens. Done. Let's go back to Live Desktop and hit F5. So we just took that program that we persisted, that we wrote in C# in all its glory, took that, loaded it in Python with sort of one line of code, that same exact model, asked the script engine to execute it, could have been on the client, could have been on the cloud, and look who's back. Come on, now that's really cool. Now, so that's resource scripts. There's a lot more to it. There's only so much we can go into in terms of depth on it, but we can spend endless hours sort of writing lots of funky, fun scripts. That's that. Okay, let's go back and we have. Let's talk about data extensibility. And for that, don't really need a lot of slides. It's kind of self-explanatory. The notion that Microsoft will get it right in terms of providing all the data types that are needed in this model is just ridiculous. Obviously, I expect us to probably get, 10% of the interesting data types in the world right. You really have to depend on on sort of third parties in general, the ecosystem, to define what are the interesting data types in this world. And there's a couple of interesting responsibilities that come with extensibility. One of them, and if you think of the 2 dimensions, there's one extensibility point that says, hey, it's specific to a particular application. And you say, okay, this app really wants to add type foo, and only it will ever understand type foo, and all it wants is for foo to be available on the cloud and on devices and have the benefits of sync and notification and serialization to multi-formats and resource scripting, whatever. And that's kind of interesting. That's like adding your own custom reg keys and your own custom binary format on disk. We all do it. It's good. There's a different style of extensibility that is, I would say, a more responsible style of extensibility, which says, in this world, it is really useful for applications to share data and share them responsibly. And by share data, it's more about sharing the data formats and the way you interpret all this data. And the power that gives you, a lot of times we're kind of anxious about it because, man, it's my data. I don't really want other apps to use it. Like, I have so much business value invested in it. But as you see, like, those walled gardens of data are going to start collapsing pretty quick. Even if you own a really, 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 really important piece of data. Give you an example. Take contacts, for example. Contacts, if you're a Web 2.0 style company and eyeballs is essentially all you have to make money, and all you care about is essentially the people in your app, whether you're Facebook or Flickr or Twitter or whatever. If that is your core asset, you're not excited about giving up that asset and documenting and opening up the way you store that particular data type that means so much to you. But even that kind of walled garden is starting to fall apart, right? People are agreeing on common ways to exchange contacts. Portable contacts is one example. If you think about identity, people are starting to agree on how to share identity, which is really people. It's such a huge resource on the web, using things like OpenID. People are starting to document. You're seeing all these organizations in the world coming up with standards, per se, to exchange different kinds of important data types, calendars, blah, blah, blah. And they're betting on that interoperability is really going to win in the long run. And all these walled gardens of protected data stores out there, whether they're on devices or in the clouds, they're going to come crashing down because people will demand, users will absolutely demand portability of their experiences across services, devices, software. And you really, how many people actually are US citizens or Americans? Oh, half, excellent. In the US, like if you were, not too long ago, remember when you could never change your mobile phone number from one company to another, and they essentially had you locked in by the virtue of having that identifier on you. You're like, man, that drives you nuts. You demand choice. You demand the ability to take your data anywhere you want to. Because honestly, we have the sentence that we use at work almost every day. Your data is your data, plain and simple. I'll go as far as we have actually contemplated at some point, we didn't end up doing it, but we actually contemplated it, actually encrypting all the data that you push into the mesh in such a way that we couldn't even read it. Because if it's your stuff, you should do whatever you want to do with it. And we are just a service for you. The challenge with it, of course, if you encrypt it in the way we can't read it, then you can't index it, you can't generate thumbnails, you can't search. There's a lot of stuff you give up. But the notion still remains that your data as end users really belongs to you. The applications you use should be, if today I want to use this photo editing app and tomorrow this photo editing app, I should not be locked into that format. If I want to use this social network today and this social network tomorrow, I want to be able to switch and take my friends with me, take my photos with me, take my devices to a different provider. And so kind of harping on this because interoperability, and this is also why we have such open protocols and open schemas and universal accessibility and all that good stuff, is because it's sort of the P0 or P-1. This world will never succeed if we all start building software again. The whole point is to break apart the digital islands, not build more of them. And so there's a portion of data extensibility that really hits at your responsibility as developer to figure out where you can be as interoperable with each other as possible and where you have legitimate business assets to protect. So your end users can really benefit from those great interoperable experiences, and you're not locking them in unnaturally, so to speak. Nothing wrong with locking in your user to your experience because you want to, again, benefit your business, but doing it in a responsible way. So extensibility comes at this from a different point where we want you to add nice data types. to live framework, but we prefer that you spend some good time thinking through how should the data look like, what other applications might find it very useful, where will I benefit by other apps actually contributing data to this place where I can do more stuff with it. And the more I'm not preaching some socialism-based system where we all do, what's best for everyone, but I like the fact that you're laughing at that. But there's some truth to it where there's basic needs for us to sort of help each other out to some degree. And if you contribute data to the system and other people contribute data to the system, both your applications will be better off. And so I'll show you, the very basic elements of how we're thinking through extensibility. And I'll caveat by saying this is a pretty young area for us because we do think it's really complicated, from providing a world where not is it just extensible schema, but that it's indexable and queryable, and you could change notifications on them. You can imagine, you guys are reading code while I'm talking. You can't help it, I know it, it's okay. There is something about extensibility that's complex in the data center. It's a little easier on the desktop and on the server, but in the data center, we are super, super sensitive to massive amounts of data that we have to replicate across data centers in the world, have to index, have to query. It costs massive amounts of computational power, and it really costs us money. When you take SQL Server and you put it in your data center and you write really bad queries over really large data sets, it's your problem, it's your CPUs you're buying. But when you do this in our data center, as much as we'd love to provide the service for free, it costs us a lot. And there's many things that we compute, the dollar amounts of how certain queries cost us to execute, and the numbers. When you're talking about 100 users, 1,000 users, we're talking hundreds of millions of users. The load and the cost of running these things is, even for a company with the number of billions of dollars we have in the bank in cash, is just staggering. And most VPs are not excited to see in their cost center and their P&L the cost to run these queries by third parties, $200 million. Fuck. So we'll edit that out before we post. So let's talk about extensibility. I have there'll be a great Channel 9 video on this coming up this week. It'll be on my Meshmobile, something I'm very passionate about. It's a carputer, if you want to call it, that runs a live operating environment and exchanges data with other devices and things like that. It's very cool. One of the things I wanted to do is be able to contribute custom data, in this particular case, the GPS location of my Meshmobile as it's driving around, that I could then share with my buddies, and I can look and see where the car is at all time. A bit of a control freak, if you haven't noticed. And I wanted to contribute very, very basic data, such as latitude and longitude of the vehicle. And I don't want to have to, do some huge amount of work for this. I just want the framework to take care of it for me. So what we decided to do as a step one is we support basic data contract style extensibility. Mark up your class. So let's say if you create a geolocation class, you have 2 members in it, lat long, mark them as data members. And we'll take care of essentially taking that, serializing it into the framework, storing it with whatever object you decide to extend on. So most extensibility I would expect to see at the data entry level. So remember, you have mesh, collection of mesh objects, which have collections of data feeds, which have collections of data entries, which have media resources. The item that I expect most of you to kind of want to extend is that data entry, because you can have lots of them, you can relate them to feeds, but you can extend other things as well. And so our initial sort of foray into extensibility allows you to very easily persist data on that data entry. So let's take a look at this app. We're going to connect a live operating environment. You all know how to do that in your sleep now. Create a new mesh object called my geo mesh object or custom geo object. Create a new feed in there, and we'll call it the geo data feed. I can create as many feeds as I want. And this is the interesting part. This is the custom class we just created for location. This happens to be, I found this yesterday on LA, happens to have this lat long, so we're here. Create a data entry, very easy. And now let's look at this method. What we're saying is take your data entries that you've created, either ones that exist or ones that you just newed up, and call a method called setUserData, give us the type, and give us the data itself, and we'll go to town taking care of this type for you. Now, the cool thing about it is that although we wrote this in C# using data contract serialization, when you want to extract that data, remember this world, It's all a pretty interesting story. I love this world, but there's really only two interesting things that happen in the world of software, or at least in this world. There's things that produce data and things that want to consume data. And if you're really a selfish guy, then you're the same guy who's producing and consuming your own stuff. If you're less selfish, then you might be something that only contributes or potentially only sucks data out. So think of this as a model, again, when we talk about extensibility and sharing the love for end users. You might contribute, my car only contributes GPS location. It does nothing with it. It doesn't care. It contributes it in, and I have a bunch of other applications that read that data somewhere else and do something useful for me. And so when this guy gets serialized in, when somebody else reads it, whether they're reading from JavaScript or Silverlight or PHP or whatever, they'll still be able to get these objects out with their types in a mechanism that really makes it easy to share this style data between applications. So that's setting user data into the mesh. Now you can go ahead and add that data entry into the collection. Notice that the same way as we did with resource scripting, we can take this data and save it in different formats, save it as JSON, save it as POX, read it, persist it, manipulate it in whatever tool we like. And now just to make sure that this data really got persisted and we can extract it, you can just as easily call get user data on a data entry and extract that out. So let's go ahead and execute this guy. And we'll pause on that, and then we'll go take a look. So we're getting an auth token, we're creating that mesh object, we're creating the data feed, we're creating the data entry, we're adding custom data to it for geolocation, and we will be done momentarily. And then we'll take a look at the serialized version of it. Then we'll go in through the resource model browser and actually take a look at it in a completely different format that has nothing to do with with .NET Framework or C# extensibility. So if I hit F10 over that, so this is us getting the data entry out. Notice that, again, the properties that we persisted, not as, came back in exactly the same way. They came back strongly typed. The object came back correctly. But underneath the covers, of course, the system has no idea about this custom type we defined, no idea about C# and data contracts and all that good stuff. So that's pretty cool. But even cooler, if we go look again in the file system, and let's take a look at geo.json pipe.tidyjson. A little easier to read. Look at this right here. Look at that. Is that pretty sweet, actually? Hold on. Hold it. Don't get too excited just yet. Let's just make sure this really came through. And by the way, naturally, because of how you've seen the live framework work, you can get at that data on the client. It's naturally synchronized with that data entry everywhere it's going. So you can go to your mobile phone, look at that data entry in the local cache. It's going to look the same way. So if we go to, somebody said, oh, there's no O. It's okay. Everything's fine. So we'll go to mesh objects. Let's find our geo mesh object that we just created. Find its data feeds. Inside that data feed, there's the data entries. And let's find that entry. There it is. Right there, serialized. Now that's pretty nifty too. Don't you like that? Come on. Let's end it. Oh. And I'm not going to leave Don Box and his old school POX out, so just for him, let's take a look at the geo.xml version. This is the POX serialized version of this guy. Look at that. There it is. There's your object. Nice, simple, straightforward, not terribly complicated, but really gives you a lot of very powerful capabilities. Some challenges around data extensibility in the first rev in the CTP that you have that hopefully some of you have tokens to already. We ran out of tokens yesterday in like no time. I guess you guys are kind of excited about this stuff. So that's great. So some challenges around data extensibility. We currently have no support for custom queries over this data because we haven't quite figured out how to index all this massive amounts of cool data you're going to persist with us in a way that's going to scale and the way it's just going to magically work. We're working on that. They'll be coming. So you can't do queries. Notification of over a particular type is tough. But some people have already figured out some pretty clever ways to get around this. So you can persist, for example, you can persist hashes of your data into portions of the data entry that we do index and have queries on. That's kind of clever, I thought. People find all sorts of interesting ways around it. And of course, with your data extensibility, the other neat things, you can extend metadata like this, or you can also extend blob data and attach that as the media resource to it, so you can really move your data around in pretty creative ways. But we really are thinking about it initially as a pretty lightweight way for you to add data into the system, and certainly not like I wouldn't take your terabyte SQL database and like, ooh, let's represent all these tables as custom extensible schemas. Don't do that yet, please. Or you'll be getting an email your account has been disabled. And then you can call me. So some tips and tricks about programming against the client, as you've seen today. It's amazing. This thing has only been, I'm going to go back on. This thing has only been out. We only announced it like 12 hours ago or 24 hours ago, I guess. And I'm already getting emails and questions in the hall of, how do I do foo? And I'm like, I thought it'd take you like a month to get there. But you guys are really moving along, so I'm going to give you some tips and tricks that I just wrote up this morning. Some people ask, hey, if I want to blow away all my data on the client and resync, how do I do that? We have 3 directories, the database, which is local, the media resource, persistent local cache we have, and the assembler that puts data together. If you delete those from your local file system, you're essentially starting from scratch. Next time the client will sign in, it will resync all its data, and you're good to go. Really easy. You guys will probably do that a lot. All our local metadata is in SQL CE. Hint, hint. Go to town, feel free. Of course, we reserve the right to change all of those schemas up anytime we want. I wouldn't depend on it. Obviously, use the live framework. Don't go to the underneath store, but you guys are always interested in this kind of stuff. Please copy the databases out of the runtime directory before you muck with them, because you're going to cause lots of bad things to happen if you do that in real time. Resource model browser, which, by the way, our buddy over here gave a great talk yesterday. Raymond's tool is going to be your best friend for the next few months. It's the best way to inspect what's going on in the cloud. It is the universal truth of what is going on in the mesh. Don't believe anything else you see if it's in there. That's what the system sees. We use it every single day. It's a great way to figure out if the bug is in the client, the bug's in the cloud, the bug's in your app, what's going on. And yes, we are going to have bugs. Imagine that. Feel free to tell us about them. Monitoring the size of the assembler directory versus the media resource directory locally is a great way to know and measure sort of progress in our synchronization system. So yes, there are ways you can check, is this object synchronized yet, and what's the sync engines doing, stuff like that. But generally, if you are moving a lot of data around between all these devices, especially when we introduce, currently the CTP you're in does not enable the peer-to-peer functionality for you just yet. It'll be coming very soon. That is enabled if you're in the end user cloud, but it's not enabled in the developer sandbox yet. If you're wondering about what's going on with sync and enclosures, you can go look in there and sort of compare and know how progress is. Logs. We believe in logs so much that there's actually a tool that comes with the developer runtime. You can just click on it, it'll collect the logs, and you can send them to us. We look at all the logs all the time. So I've had somebody once tell me that, I was like, do you ever click that send error port in the Watson dialog box? No, I never click that. You guys are insane. Always click that. It's the first thing we look at. We collect all of them. We look at all of them. They're super helpful to help us debug, and we fix bugs much, much, much faster when you give us logs. So please make those your best friend. Go look at the logs. They're kind of interesting and nifty, I think. Some summary words. I'm going to touch again on the service composition element of the live framework. Again, think of, some folks think of the cloud as just another device in your mesh, which is a great way to think about it, because in the real world, it should just be a peer. It may be a superior peer, has some more capabilities. It's always there for you no matter what. But it is just like another device, and that is one of the reasons that the live framework programming model looks and feels the same across client and cloud. It's symmetric, it's platform agnostic. There's a lowest common denominator approach if you choose, but honestly, I think 90% of us will pick some API kit we really like. And please, I beg you, please go out there and start blogging your own custom API kit for whatever thing you want. Share it with the community, get that going. We'll fully support you if you have questions. Everything's a resource. Learn and to live, breathe, and love it. URIs are your best friends. We use standard HTTP, again, for everything. And the point of the system is to be simple and open, and where we're not, again, we'd love to hear your feedback on where we could be doing better on this front. So with that, before I take questions, I'll say thank you very much, and I hope you enjoy playing with the live framework. Lots of great sessions today. I'm going to take lots of questions now. We have plenty of time to take questions. Please come up to the mic and ask away. If you're curious about other sessions where you can learn more in depth about particular elements of the system, they're on screen. Oh, and we have some killer live framework posters here for you if you want them. They're really, really cool. They're the coolest developer poster we've made yet. And I know we all have them, so feel free to come. We have like hundreds of them. Come grab some. Here. Go ahead.
Hi, Ari.
Hey, how's it going, man?
Daniel here. So, what's the story for like synchronizing multiple items using like a sync feed on one side and the live mesh on the other?
You always want to go straight to the heart of the matter, the hard questions. Come up, your questions are the most complicated. Come up and we'll chat about them. Where's Steven? Is Steven here? Come chat with Raymond real quick. You are the most advanced developer in this room. I think, geez, you guys. It's not candy, and it's not a lottery ticket. It's just a poster. Look on the backside. See, half the poster has got this matrix rack look and feel. You can take more than one. Don't be shy. Go ahead. Sorry, question. Somebody just raised. Oh, I see. Poster is more important than your question. What a mistake that was. All right, get your poster, then ask a question.
Question on the
Go ahead.
The data contract that you used, I noticed for the geolocation, latitude, longitude was a string instead of a decimal or a double. Are there limits on the data type? Do they have to be string?
Sorry, I was just lazy. There are some limitations, of course, over really complicated types, but generally anything that supports data contract serialization, you'll be fine.
Okay, cool.
Cool.
A quick question regarding running scripts on the server, on the cloud. Can you trigger these? When can you have a trigger on these? So yes. some event happens, some interesting data gets loaded up into the cloud, and you get this event, and you go, wow, this is an interesting event. I need to invite these people to this folder that I'm going to create and have some work done. Can you do that?
Can you trigger over resource scripts? Yes, there are triggers. You know, that's next time I'll show you actually have to attach triggers as well. You can attach them to the basic CRUD operations. And it's difficult. You can't quite attach them to any type of an event, but if the state change is something that's persisted, like a news entry or something like that, or something that you generated, on reading of that, you can execute essentially a script, and that gives you similar sort of functionality. We're still pretty much in the early days of resource scripting. We're experimenting with them. We're just putting them out to get some feedback. We're going to add a lot of more capabilities. One over eventing is particularly a good one. But again, it can cause the system to get into some pretty funky states. If you imagine every time a state changes, you execute a script, it changes the state, something else starts executing. Like, it's a design.
Okay, thanks.
Somebody asks. Go ahead.
When are we getting our invitation codes?
When will you get your invitation codes? You didn't get one?
No.
Did you go to the hands-on lab?
Yes.
Did you complete the hands-on lab?
I've completed the first one.
And they didn't, there you go. You're about to get one, I think, in about 2.5 seconds.
Only one of the labs requires a token, so you should make sure you run the lab that involves building a mesh application, and they will happily give you a token.
We still have tokens left, right, George?
Yes.
Excellent. There's your answer. If you complete the lab that requires a token, it's the fastest way to get it. Otherwise, there's a waiting list, and we'll provision people sort of on a first-come, first basis. But if you want one today, do the lab. It's actually pretty fun. Do the lab. It takes a few minutes. You'll get a token, and you're good to go.
Okay.
Cool.
Is that for data services in the other environments as well?
I think you're only going to get a mesh token or a live framework token.
Okay.
If you complete the live framework lab. But at the same labs, you can get tokens for the other services as well. It's not a problem.
Okay.
Cool. Party. Go have fun. Other questions? You can come over here. You don't have to go to the mic. That's fine.
In the case where you are not syncing with the cloud, but essentially you're setting up a sync between two devices, can you still get access to the resources through the live operating environment?
Absolutely. Absolutely. So the live operating environment is sort of agnostic of whether you create what we call a mapping between your object and the cloud. If you don't want to map it there, that's not a problem. The metadata for that object, we still use the cloud as a central point for essentially think of it as doing conflict resolution between devices. It's the ultimate arbiter. The data for your object, the actual media, like the resource, the media resources, do not have to get mapped to the cloud, but we'll still keep track of the metadata to make sure that we can resolve conflicts appropriately, apply permissioning. But you'll be able to get at the schematized data locally, whatever custom extensibility you did, no problem, on the clients themselves. Cool. Good, clever questions. Yeah.
So what happened to the web services and underlying SOAP? Is that too complex for this approach? And that's why you are basically promoting the HTTP methods to get to the cloud, to put something into the cloud?
That's a great question. So what about SOAP? Actually, we nothing against SOAP. SOAP's great. We thought initially going the CRUD way, the lightweight, sort of cloud operation based over HTTP, simple, will give us better, we talk about universality a lot and being able to be easily accessible from any device, platform, runtime stack, etc. So there's nothing that prevents you from overlaying SOAP really over. And if enough customers say, hey, we really want the SOAP endpoint on that, we'd say, okay, no problem. We'll give you a SOAP endpoint. And the architecture we picked allows us to very easily add what we call heads. So we have right. So we can easily add another one. Honestly, we just haven't gone to it. And when customers say we want one, we'll probably make one. Is my guess. We don't have any plans to right now.
Okay.
It is a little bit heavier weight. There's some,
it is. Yeah.
And for the kinds of things, a lot of what we do is the minute, especially you're trying to include enterprisey as well, because you want all to be welcome to the party, not just enterprise. It'll be hard to go to a company like, and I'll just pick whatever, Twitter, and say, hey guys, come, let's wire up your stuff and our stuff, and oh, by the way, you have to use SOAP. And they're like, what is that? But again, nothing fundamentally against SOAP. Love SOAP. SOAP's great. We actually are, a lot of the capabilities, WSDL style, the ability to project it for tooling and rich binding, you'll have the same over AtomPub, and so.
Okay, thanks.
Okay.
It's really AtomPub and REST that is your lowest common denominator.
Yeah, to a large degree. You still can project over, if we really wanted. I'll tell you, the funny thing is, these days, we have, because this is different how other companies in the industry do it a little bit, but we have some responsibility to make sure the stuff we build has longevity sort of built in from day one. So if you imagine what over the next 5-10 years, like every 6 months some random dude on the net invents yet another, ooh, let's do this protocol today. This is really cool. And a whole bunch of Zelics put on the hat and yeah, let's go do that. And then who knows what random format will show up next. And we'd love to be protected as much as we can in the sense that we want to be able to add support for all these things as easily as possible. Portable contacts is a great example. So a bunch of industry leaders are getting together, coming up with a common way to represent contacts, and we can add we actually already added support for that in a matter of a few hours, and you're like, hey, here you go, head for portable contents, you're done. So the system is designed with that in mind from day one. I agree. Elegant, lovely, simple. It's beautiful. It's happy. I wear that on my underwear, not T-shirts, but that's good.
So this is a bit of a sensitive question, but
No, sure, fire.
Microsoft as a company has embraced adopted stack kind of had in the past. This sounds very different. It sounds like this is a new, very different interoperable Windows.
We like to think so. The way I typically think about it is that we usually tend to do, we're a business like any other business, we tend to do what our customers tell us they want. And so when interoperability becomes as important as it is today, between everything, enterprise system, open document formats, if the community votes with its feet, if our customers vote and say this is what we want, and they're smart, at least as smart as we are, if not a lot smarter, they know what they want, and it's like what business doesn't want to do what its customers want? And plus, it really, it helps us a lot, especially when you're talking about bringing the digital world that is not dominated by any particular player. Standards are a good thing.
It's a great story.
So we think so. We're excited about it. So awesome. Thanks. Hey, Dietz. How's it going? Any other questions? I think we're about. That's good. You guys can come up and chat.